Hello, good day, and welcome everyone to the DOSI 10-year anniversary webinar series. My name is Christopher Barrio-Frojan, and I am the DOSI Programme Officer, your host for today's webinar. This webinar is the third of 6 in the series, and we're delighted to bring to you some leading voices on the topic of deep ocean pollution, namely Agnes Wangui Muthumbi from the University of Nairobi, João Miguel Pereira from the University of the Azores, and Rufino Varea from the Pacific Islands Development Programme. Please spare a thought for Rufino, as it is currently 3 a.m. in Fiji, where he is based. Without further ado, I'll hand you over to today's presenters, and hopefully I'll see you all again shortly when they have finished. So first of all, João, over to you.
So I'm João, I'm a PhD student in the University of the Azores, and I'm also collaborating with the University of Exeter as my second host institution. I will take you today with me into the deep sea, where I will explore very briefly, the plastic pollution in the deep sea, a 10-year story. So this is an outline so it can help everyone to follow what I'm going to be through. So I will try to explain very briefly what is the deep sea, the issue of plastic pollution, why looking in the deep sea for plastic pollution, what did you learn in these 10 years about quantities, how it gets there, interaction impacts. I will explore a little bit the limitations and what I think is going to be future directions for the work. So what is the deep sea? I'm pretty sure most of the attendees know what is the deep sea, but I will very briefly explain. So the deep sea, it's all the ocean areas below 200 meters. It covers 65% of the planet's surface, and has a lot of different environments to it. It's cold, it's dark, high pressures, limited food supplies. The organisms that live there have long lifespans, are very adapted, and sometimes they can be vulnerable to rapid changes in the environment. Plastic pollution. So we find plastics everywhere in all terrestrial environments, from the atmosphere to the deepest points of the ocean. Right now, over 400 million tons of plastics have been produced annually. And from this growth estimation, up to 12.7 million tons of plastic can enter the ocean annually. These estimations need to be actualized and need to be updated and needs a little bit more information, but this is just rough numbers just to give an idea about what is reaching. So this recent study by Ericsson estimated that up to 358 million trillion of plastics in the plastics are afloat. And this is only a portion of microplastics and plastics in general afloat. There's a lot of that in the deep sea or on sea floor or stranding on coastlines. Also, as you can see in this little image in here, that is just used to explain a little bit that most of the studies have been close to coastal areas or in pelagic areas, but close to coasts. The further away you get from the coast, the harder it is to get some samples, and there's a lot of data points missing. So I will speak about these two worlds. When you look at plastic pollution, there's two worlds, the macroplastics and the microplastics. Each has different challenges and different methods, and it's a completely way to look at it. So in a very simple way, microplastics are all the artificial polymer from 1 micron to 5 millimeters, and microplastics from 5 onwards. So through the presentation, I will speak a lot about microplastics and microplastics, and I will try to explain a little bit the differences and what is being looking at each. So what about the deep sea? Why looking at the deep sea? So we were finding that there was a lot of plastics stranded on the coast and on the surface, but there was a limited information about what is the plastics below the surface. We knew that were microplastics, like stranded lost fishing gear, and some microplastics that were being founded. As already reported in studies, there's some studies from the 80s and the 90s that reported that sometimes was finding some litter on the deep sea, on the bottom, but there was not much information. But in 2014, this study came out that looked at the microplastics in sediment in the deep sea and found relevant concentrations of microplastics. And from there was suggested that the deep sea can be a sink for microplastics. And this was an initiation process to look at the deep sea and try to understand. It's still for discussion if the deep sea is really the sinking for microplastics or not, but a lot of studies came from that. As you can see, it's a new area of research. You can see clearly in this bar chart there was a boom of publications after 2017, most of these publications have been in microplastics. So the microplastics got a really huge contribution in this field, while the microplastics was already started before 2013 and keep going a little bit. It is a little bit more developed than the microplastics. There's different study habitats. What is important to look at here is that most of the habitats are on the seafloor. So most of the data samples are on the seafloor. There's a lot of data information on the water column, and most of the habitat samples are also close to shore. So continental slopes, canyons, and a little bit of bathypelagic plains. Also, when you look at mesopelagic, that has a huge contribution is mostly on fish. So quantities. This takes us to the beginning. The beginning was trying to understand, okay, we are trying to understand how much plastic in a deep sea. Is really a lot of plastic in the deep sea? Is the plastic everywhere? So that's where the first studies came out. And that was the initial focus on was the abundance of plastics and macroplastics in the deep sea. So recently has been estimated that around 2 million tons of microplastics are accumulating in the deep sea. This accumulation is not uniform, as you can see in this example table. Some trenches can accumulate a higher concentration of microplastics per area. However, it's a small area, geographic area, so there's a lot more plastics accumulating in other areas that cover a little bit more of the ocean surface. Also, this study reviewed a little bit of the macroliter in canyons. Canyons are known to be an accumulation for microplastics, and so worldwide, 128 billion of microliter can be found in canyons. Obviously, this is only one section of the deep sea that we know that accumulates a lot. And when you look at microplastics, we know that a lot of plastics are also accumulating in fishing areas with lost fishing gear. So how does it get there? Microplastics can get there through different ways. So one important thing, one of the most studied areas are the fishing areas. So you can find a lot of information about abandoned, lost, otherwise discarded fishing gear. So there's a lot of information about fishing gear and so on. This leads that ocean-based activities can have an important contribution in the ocean litter distribution. Also, cruises were known to release a lot of plastics and to polymer density, some of the plastic sinks, so plastic dumping. But this plastic dumping can also come from bad, mismanaged waste. So it comes from coastal areas and are being pushed through some currents, Turbulent currents, and they're pushed to the bottom, eventually reach the canyons or the continental slope and reach to the deep sea. Also, it's important to understand that some plastics are surfacing and they're colonized, and then they start immediately sinking slowly and can reach the deep sea. So colonization can be one of the processes to vertically transfer plastics from the surface to the bottom. When you look in the microplastics, things get a little bit more complex. So there's a lot of processes. So macroplastics can degrade, fragment in small plastics and become microplastics. But in a very simple way, what is on the surface can be colonized by bacteria or small organisms, so biofouling, and start to think slowly. They can also aggregate in areas of primary or secondary production, aggregates with organic matter, so particulate organic matter, and starts to think. This is just an example to exemplify the thing, and it goes slowly. So it doesn't go very fast, doesn't reach the deep sea floor, can take years to reach there, and could go down and up a little bit. So that's what are being called the marine plastic cloud, in the general term. So also we need to look at organisms. So organisms that do vertical migrations can transport plastic from the surface to the bottom and vice versa. We need to look at sea currents. So as I explained before, sea currents can push litter from coasts to the deep sea. The same can appear with microplastics and then are being pushed from here to turbulent currents. When they reach the deep sea, doesn't mean that they sink and they stay there. No, can be some bioturbation, can be some currents pushing a little bit more. So the plastics move from one area to another area and are being transported currently. In some areas, they can accumulate more, like the trough, because it's a closed area, but it keeps going. And it's also important to understand that upwelling can transport plastics from the deep sea up to the surface, something that we could consider like a plastic circle in the ocean, for example. Interactions. So microplastic interactions are a little bit more to visualize. You can have visual interactions, and the most visual one and reported one is entanglement. and smothering. So you can see a lot of fishing gear, fishing lines entangling with organisms or being entangled in coral reefs, for example. 1/3 of the coral reefs in deep Arctic have been found with entangled fishing gear. Smothering is also common to find, for example, fishing nets covering some corals or sponges with potential impacts to it. We also have the colonization that can be argued as a positive impact. So it can offer refugee and habitat for some organisms, but this is up to discussion because you need to look at pros and cons and still an introduction to an area. And we have ingestion that have been reported. However, ingestion is a little bit harder to quantify on microplastics. Microplastics, most of them are being reported in ingestion, if you look at it, but I will speak in here as an incorporation. So incorporation can include ingestion, retention in gills, or other parts of the body. So has been reported in several taxa of the deep sea of different trophic levels, as you can see in this example image. Most of the taxa that have been sampled were found with plastic. However, there's no indication of trophic transfer of bioaccumulation, probably because plastics are small and they can go through the digestive system and be released. One mechanism of interaction that is often overlooked is the adhesion. So we know that, for example, in corals and anemones, in shallow waters, plastics can be attached to the corals, and it's been already referred as a potential sink for microplastics. This can also happen in the deep sea. There's not much studies doing that. Actually, I did a study last year with deep sea corals, and where you can see in this little image, where I exposed the corals to plastics, and a lot of plastic got attached to the mucus. So this is expected to happen also in the deep sea. Microplastics impacts are mostly visual. However, there's not much information about what is the physiological impacts of this. Again, fishing areas are very studied, so you can see clearly impacts as mortality from ghost fishing, but it's also important to understand that entanglement and smothering can have direct impacts as abrasion and tissue damage, as you can see in here in the image. What is the true impacts to the long term of these organisms? We are still being studied, but you can see clearly what is happening due to these kind of interactions. Also, has been reported some ingestion in microplastic ingestion in some organisms that have been potentially causing some obstruction or irritation in the digestive tract. However, more studies need to be done in this case to understand everything what is happening. Microplastics are a little bit more of a silent threat, and the impacts are much harder to understand because you need to go in more in the physiological side and understand a little bit more what happens inside. There's currently less than 10 studies studying the physiological impact of microplastics in organisms, and most of these studies have been made with corals. Corals have been chosen because some of these coral species can be maintained in laboratory conditions, and also because they have an important ecological role. So, some of the things that have been reported has been the decreased feeding rate, the decreased growth, increase of respiration, molecular stress, altered by microbiome. These concentrations have been very high, but can have a direct impact on the organisms. So more studies need to be done in this. Some limitations. So as I explained before, it's a huge area to cover, and it's expensive and hard to assess. So we are limited in some data points, and this limits the data we can get. A lot of the studies were to develop methodologies and to understand a little bit what was happening. So there's a lack of standardization. It makes it hard to compare some studies. So it's very hard to compare studies that have been in the past and studies that have been now. So lack of standardization has been a limitation in this area. Also, is a poor understanding of deep sea organism biology. For us to understand how the organisms are going to be impacted by microplastics, we can understand better the biology. So this has been a limitation on how we can interpret the data. This is a little bit the future directions that I've been thrown through. So we need to go and standardize the way we do the methodology, we analyze the data, and how we report it. There's a lot of new technology being developed, could be for helping AI with imagery, but can also be new technologies for sampling, more specific technologies, because we have been using technology for other areas and adapting a little bit for plastics. So trying to get a little bit more and better technology, maybe it can help us also get to long-term monitoring and getting a data set that is more complex. It's a better understanding of the impacts. It's really important. It's like I explained before, there's not much information. We need to go on that. And when you look at impacts, we also need to look at the multi-stressor approach. Microplastic pollution or plastic pollution is just one stressor. We need to look at the effect of plastic pollution with other stressors like deep sea mining and contamination, etc. Thank you for your attention, and I hope you understood everything.
Thank you very much, João. That was very clear. Now, we must apologize to our audience. We've had trouble connecting with Agnes, but I can announce that she is now with us. So welcome, Agnes, and the floor is yours for your presentation.
Good evening, everyone. My name is Agnes Muthumbi, and I'll present to you this evening review of plastic pollution studies in the Western Indian Ocean region. This work was done together with my student Agnes Wangui, a review of all papers that have been done in the Western Indian Ocean. So for the outline, I'll do a short introduction and then look at the geographic distribution of plastic pollution studies and the number of studies in the different marine environments. Then we shall look at the number of studies in the different compartments of marine environments and the number of studies covering different size categories. And then a short comparison of methods that have been used to study microplastic pollution within the region and a short conclusion. So for the introduction, plastic pollution has become one of the global planetary crises, joining climate change, biodiversity loss, and pollution. That, of course, includes plastic pollution. Oceans tend to be impacted more because of being final recipient of all the pollution, including the plastics and microplastics. And all compartments in the marine environment are impacted, that is water, sediment, and the marine organisms. Contamination in particular of marine organisms that are important food source for humans has implications to human health. And this has caused the need to have a global plastic pollution negotiation to have zero plastic pollution in the environment. And so we ask the question, how prepared are we in the Western Indian Ocean region to tackle the challenge? So we look here at the geographic distribution of the studies. And we did a review of studies that have been done in the region from 1988 to 2024. We came across 84 studies in the whole region. And then looked at how the distribution of these studies within the countries of the Western Indian Ocean. 10 countries with 5 coastal countries and 5 island countries. And looking at the distribution, you see here that South Africa has the most number of studies with 38 out of 84, and that accounts for 45% of all the studies. And next is Kenya with only 18%, less than half of the studies in South Africa. That amounts to 21%. And the other countries, Tanzania, Mauritius, with 7 studies, that is about 8.3%. And there are still countries with just 1 study that has been done during that period on plastics. And so we see that the coverage of plastic pollution studies in the region is very low. And there is huge disparity between countries in the region in the effort to understand plastic pollution. Then we looked at plastic pollution studies in the different marine environments, whereby we looked at the nearshore and the offshore, and other papers that are simulation or reviews. And we see that about 76% of the papers were actually nearshore, and only 8% were studies offshore. and about 16% were studies that were done as reviews or simulation. So generally, we see many more or a higher proportion of studies in the nearshore. And so we realize then that there is little ability to cover or to do the deep waters or the offshore studies. And so the question is, how can we partner with other international, regional, and national agencies to venture into this less studied environment, the deep environment, which is also very important to understand what is happening. Then we looked at the number of studies in the different marine environments in the different countries. Same thing, nearshore, offshore, but in each of the countries, and just seeing what are the proportions of each. And you realize that actually most of the countries that have done anything offshore is much lower, expectedly, of course, much lower than what is done in the nearshore. And some countries have not even ventured there. So offshore studies are relatively very few in different countries. In fact, some countries have not done any offshore. And so there seems to be a problem with capacity that can enable scientists to go offshore in the deep waters, in the deep sediments. And so this is an area that is lacking and may need to capacity build. Then we looked at plastic pollution studies in different marine compartments. And here we are looking at compartments such as the sediments and the surface waters and in the organisms. And in general, there are more studies, of course, in the sediments than in the water column, with 48% and 28% in the water column and 24% in the organisms. So it looks like sediments appear to be more accessible than the water column, and that could explain why there are more studies and less studies in the water column and the surface waters. Perhaps because some investments are needed to study the water. You may need to use a boat, you may need to use some sampling equipments that may not be easily available. So again, just demonstrating the inability or incapability to do certain studies or to study plastics in certain environments in the region. And similarly, the number of studies in these compartments per country, we see again that the same thing, that a few countries, different countries have been able to do more studies in the sediments than in the water column. And also less in the organisms. Apart from South Africa, that seems to have a third of each, a third studies in the sediments, a third in the surface water, and a third in the organisms. Most other countries, they have much less in terms of what is done in the water column. And that seems that sediments may be much easier or much more to access than the water column, in the sense that with the sediment you can easily walk into the intertidal environment, take your samples without any more investment. Certainly, if we were to look at how this the distribution of the studies in the sediment, I would expect that there is a lot more in the intertidal compared to subtidal and anywhere else. Then we looked at the distribution of studies of different plastic size categories, whereby the size categories we were looking at as microplanktons, mesoplanktons, and macroplanktons. And with the microplanktons, at least 49%, almost 50% of the studies were in the microplastics, and 41% were studies on macroplastics, and only 10% in the mesoplastics. And while mesoplastics may be something between visible with the naked eye and not visible, and those that may need a microscope, it is still not clear why the focus on mesoplastic is so much lower compared to the other two sizes of plastics. Then we looked at the differences in the methods in microplastic analysis. Here we focused only on the microplastics and not on the meso and macro. So for the microplastics, we looked at the analysis, sampling, sampling techniques, the analysis techniques, and so on. And what you realize is that the sampling techniques are so varied, whereby some of the studies or some of the scientists use the manta throw, some use the bulk sampling, some use the plankton nets or the pump. The mesh size was also varied from 20 micrometers, 80 micrometers, to even 500 micrometers. And when you look at the laboratory procedures, again, some used sieve and counted, some digested in potassium hydroxide, others used hydrogen peroxide, and then the size for the filter papers for filtering, the digested the filter papers for filtering the digested samples also varied from 0.8, 2.7 micrometers, even 20 micrometers. And the units for reporting again varied. Some used the number of particles per meter squared, number of particles per meter cubed, or number of particles per liter. Looking at the segment analysis, analysis also varied, including the sampling. Some sampled using a spatula, bulk sampling. There are those that have used a Van Veen grab, metal spoon. And even for those that may have used a hard chorus, they took samples at different depth. 1 centimeter, 5 centimeters, 10 centimeters. There are all these variations. Drying, some dried in oven drying at 40 degrees Celsius, some at 50, and some at 60 degrees Celsius. And again, the digesting chemicals also varied. Similarly, like in the water column, or samples from the water. And the chemical for flotation also varied, zinc chloride or sodium chloride. And the size of the filter paper, again, they were also varying. Units of recording again varied, with some being particles per microplastic particles per dry weight, measured in kilograms, and some in grams. So we see a very high variability in terms of the way these microplastic studies have been done. So some of the observations are that more studies in the nearshore waters than offshore, and there are also more studies or more focus on sediments than water column. We also see that there is focus on microplastics, macroplastics, and less focus on mesoplastics. There are also more studies in the plastic pollution in some countries in the Western Indian Ocean, like in South Africa. Others have very few, and some may have no studies. And very few papers had focus on polymer type identification. The challenges that we notice is that there is the level of funding and infrastructure required for offshore studies and water column may be beyond affordability for many countries in the region. And perhaps also the capacity to do that may also be lacking, and so maybe benchmarking would help. And there are varying methodologies all throughout the plastic pollution studies in microplastics, and this makes it very difficult to compare. Few studies have been done on mesoplastic, the mesoplastic size category, And this is a question that still cannot be answered. Why the low focus? So some concluding questions is how prepared are we as a region to domesticate and implement the legally binding multilateral agreement on ending plastic pollution? First, we do not have harmonized procedures of analysis in plastic pollution studies that can enable comparison of studies in different countries, and also for the baseline study that we can now use that as monitoring and evaluation. Then there is low capability for studies for studying plastic pollution, especially offshore and in the deep waters, as well as in the water column. So I want to stop there and say thank you.
Thank you very much, Agnes. Okay, Rufino, please, if you wouldn't mind, go ahead with your presentation. Thank you.
Okay, thank you everyone who is joining in for your time. I'd also like to thank João for setting the scene with his presentation. In my presentation, I wanted to talk about the Plastics Treaty and the developments and the progress that we have made. So this was all initiated by the United Nations Environmental Assembly, UNEA. And in 2014, UNEA passed the resolution 16, which acknowledged the negative impacts of marine pollution on ecosystem services, natural resources, fisheries, and human health. And then this was followed by Resolution 211, which focused on marine plastic litter and microplastics. And then right after, we had Resolution 37 that was passed by UNEA that called for the development of national or regional action plans to address marine litter. And it highlighted the importance of eliminating the discharge of litter and microplastics into the oceans. It also saw the establishment of the ad hoc open-ended expert group. And in its fourth meeting, UNEA passed Resolution 46, which contributed clarity and momentum to the international dialogue on combating marine plastic pollution and microplastics. Finally, as you can see, in 2022, Resolution 514 was passed, in which UNEA requested the United Nations Environmental Programme, UNEP's executive director, to convene the Intergovernmental Negotiating Committee, or INC, which was tasked with developing an internationally legally binding instrument on plastic pollution, including in the marine environment. So the UNEP convened the INC, and this was the first one, which was held in Uruguay, as you can see, INC 1. The second one was in France, and the third one, the most recent one, was in Kenya, in Nairobi. And soon, the fourth session will be convened in Canada. That will be followed by possibly the final session to be held in Korea. Once the final draft text has been agreed to, then a diplomatic conference of plenipotentiaries will be held to adopt the text and then place it under treaty. Now, what happened in INC 1, the first meeting? Here, the UNEP Secretariat called for plastic production reduction and protecting human health. This included a need for a just transition, which led to the Just Transition Initiative to address waste pickers' representation in the negotiation processes. And INC 1 was like a trendsetter of sorts, and it pushed the momentum for the remaining 4 INC meetings. In the second INC meeting, discussions were centered on an elements paper that was published by the UNEP, and it contained potential options for elements towards a legally binding instrument on plastic pollution. And the elements paper would eventually become the blueprint for the design and development of the zero draft text. Now, prior to the third meeting, INC3, that was held in Kenya, the Secretariat released the text of the zero draft, which was intended to be negotiated on based on various options which were included in the document. And the document was divided into three parts. The first part was on core obligations and control measures, and it included 12 agenda items. This part outlined what the legally binding instrument would focus on in addressing plastic pollution. Part 2 was on implementation measures, and it contained 8 agenda items. This part is basically designing strategies to track any progress on the country's commitments to the treaty that should be followed by them. And finally, part 3 was on the means of implementation, and it contained 3 agenda items. Now, this part sought to achieve resources and mechanisms that would assist or support states in meeting their obligations under the treaty. And each agenda item under the 3 parts contained 2 or 3 options, where option 1 was the most ambitious, while option 2 and 3 were less ambitious. And these options under each of these agenda items is what would be negotiated or determined on how ambitious each of these targets would be. In other words, it would determine how effective this legally binding instrument would be to address plastic pollution. And it should be noted at this point that option 1, while it was designed to be very ambitious, was in no way perfect, and some of the language lacked or missed clear and decisive targets. And here's where we needed to think about how the work was going to be facilitated, and we would have to do important work on the timelines, baselines, and targets. Now, at INC3, the states negotiated on the zero draft text. There were 3 contact groups that were established and was led by facilitators to assist in the negotiations of each of the 3 parts of the zero draft text, which I had showed earlier. And the negotiations on some of the contentious agenda items like chemicals and polymers of concern or trade pushed into the later parts of the evening during some of the days. And industry lobbyists had a wide presence, and this too raised concerns about conflict of interests, the spread of disinformation, and industry accountability. And at the end, after huddles and back and forths among member states, there was no agreement that was reached on the intersessional work to revise the zero draft. The Secretariat eventually released a revised version after the 3rd meeting of this on the zero draft, with only very minor amendments, such as on grammar. And in my opinion, the only blessing in disguise was that a compromise or a less ambitious text did not come about, leaving room for us to continue to push for more ambitious targets. Now, at the 4th INC meeting, which is to be held in April in Canada, we are left with more work to do while keeping to the mandated timeline given to us by the United Nations Environmental Assembly. We can expect more strict regulations around the rules of procedure. And with the new INC chair, Ambassador Luis Vallas from Ecuador, who is coming in, he will see a steep curb that lies ahead for him to steer the negotiations back on track. and this will likely include regional consultations to occur so as to provide input and feedback with a particular focus on refining the draft text prior to the 4th INC meeting. As for the Global Plastics Treaty at the Deep Ocean, for DOSI, the call for wide engagement is pertinent for the negotiations, considering that there is no specific mention of the deep ocean in the zero draft text. Scientific guidance from DOSI, including our collaboration or possible engagement with groups such as the Scientist Coalition for an Effective Plastics Treaty, may prove useful to push for specific language that explicitly and intentionally addresses deep sea plastic pollution. And this can include drawing on the need for a governance mechanism to be established, and our collaboration with stakeholders like CSOs, including the petitioning of the FAO to enter the negotiations, may prove helpful down the road in the development of a comprehensive and effective globally binding instrument to address plastic pollution, including in the marine environment. And with that, I thank you for your time. That ends my presentation.
So with that, I would like to thank João, Rufino and Agnes for their hard work preparing for this webinar. A special thanks to Rufino for staying up so late, and thank you all for listening in. I'll see you all on February the 14th. Bye for now.
Hello, I'm Brandon Gertz, DOSI's Director of Communications. Thank you for joining us for this webinar on pollution in the deep ocean. We still have a few more webinars planned in this anniversary series, so I hope we'll see you again. Next up is a webinar on decarbonization of deep ocean industries, which you can find a link to in the description below. Take care.